Hello. So in this video you are going to see from question 7, and this is the part of JEE Main 2020 September to Shift 1. Okay, so this is the second part video of this. Okay, so in this video the most of the questions are from mechanics 1 and gravitation. Okay, so now I am jumping to the question. So first see question number 7. Okay, so it is mentioned there are two trains AB moving with the speed of 36 km per hour, 72 km per hour in opposite direction. A man moving in train A with a speed of 1.8 km hour opposite to direction of train. Find the velocity of man as seen from the train B. Okay, so I have drawn the figure for you. So this is a train A, this is train B. Okay, so speed of train A in meter per second will be train A speed V of A equals to 36 into 2 by 18. So it will be like 5 by 18, sorry. This will be 5 by 18, so 10 meter per second. Similarly, velocity of train B is 72 into 5 by 18, so it is 20 meter per second, but in opposite direction, so use minus sign. Okay, so you can use minus sign here. Okay, so it is given again we have to find velocity of man with respect to train B. VMB is what? We have given velocity of man with respect to A is known, that is 1.8 km per hour. So if we change it in meter per second, it will become 0.5 meter per second. Just do it. Okay, you will get it. And we have to find VMB. So we can write it as VM minus VB, or VM minus VA plus VA minus VB, right? So this will become, so I am just adding VA and subtracting VA. It will not affect mathematically anything. So VMA plus VAB, correct? So VAB, velocity of A with respect to B, is VA minus VB. We know that VA is 10 meter per second and VB is minus 20 meter per second. So it will be effectively 30 meter per second. So it is a question of relative motion. Okay, so now put the value, okay, one more thing, this is in the opposite direction, so there will be a minus sign, VMA. Okay, we are taking this side positive. Okay, this direction, so using it you will get what? VMA minus 0.5 meter per second and VAB is 30 meter per second, so this will be 29.5 meter per second, correct? So this is in the option B. Okay, so this is the easy question of relative motion. Okay, many of the students were able to do this question. Now next question. So next question is the based on momentum. Okay, conservation of momentum, very basic. Okay, so it is given a body of mass m moving with ui collides elastic with a stationary body of mass 3m as shown. If the velocity of mass m after collision is u in j direction or y direction, the magnitude of velocity of 3m. So this is the easy question, correct? Now see it. So initial, P initial will be m u I plus 3m into g. So that will be m u I cap. P final equals to, you can use m u j plus 3m into velocity vector v, correct? So pi equals to pf, conservation of momentum, correct? Now use it, mui equals to mu j plus 3m v bar. Just mm will get cancelled. Now you can say that. Now solve it. Solving it is easy. So v equals to ui minus uj. Correct? V bar. So just we have to find the magnitude. Then v bar magnitude will be under root u square plus u square. Correct? So it will be root 2u. So if we have find the magnitude, oh sorry, we missed 3 here, right? So just transfer it first. Sorry. Okay. So it will be minus uj. Correct? And that will be the 3 v bar. So v bar will be ui minus uj by 3. Correct? Now finding the magnitude. Find the magnitude. That will be 1 by 3. 1 by 3 into u square plus u square under root. That will be 1 by 3 and root 2u. So the answer will be, so the magnitude of velocity, that the answer will be root 2 by 3u. Okay. So this was the easy questions. Just don't do any calculation mistakes. Okay. Now proceeding to the next question. Next question is based on the friction. Okay. First see the question. A block of mass m starts slipping from the top of the inclined plane B. Okay. And comes to rest at the lowest point A. So this is the B point. This is the A point. Okay. Of the inclined plane. If BC is 2AC. So BC is equals to 2 times of AC. Right. So if it is L. Okay. This portion AC is L, then BC will be 2L. Correct? Correct. So this is the theta, and given is friction coefficient, that is mu. So mu is given as k tan theta. Okay. So what is the value of k? We have to find the value of k. Here you can see that we have to apply the conservation of energy. So if it is coming from B to A, first find B to O. Okay. B to O height. Okay. So height will be, it is total 3L. This portion is BA is total 3L. So it will be 3L sine theta. Correct? Assume this is the inclination is theta angle. Okay. So this is 3L sine theta. Okay. And this part is the smooth. So there will be no energy loss here. All the energy loss, because all the potential energy here is going to transfer in kinetic energy. But we see at point A, it is at rest. It means all the energy is lost as heat due to kinetic force or kinetic coefficient of friction. You can say that surface friction. Okay. So you know that the force of friction force of friction is mu times n. Normal force is mg cos theta. Correct? And mu is here k tan theta. So k mg cos theta into tan theta. And tan theta is sin theta by cos theta. So it will become kmg sin theta. Okay. Now we know that this is the force of friction. So energy lost in due to friction is force of friction and the path. And this path AC is how much? L. AC is L. Okay. I have written here wrong. AC is L and BC is 2L. Correct? This is point C. So the energy will be lost is force of friction into distance traveled. That will be k mg sin theta into L. Okay, and this is equals to the total potential energy that will be converted, that was supposed to be converted in kinetic energy, that is mg height is 3L sin theta. Correct? So by solving it, you can see that everything got cancelled out and k becomes 3. So here you can see that k equals to 3. So this is integer type question, so k equals to 3 answer. Wasn't it easy? Okay, it is more easy actually. Okay, I think it was the easiest question they have asked. Okay, no, there were more questions which were more easier than this. Okay, now the next question is from the gravitation. So see this question: in a hypothetical spherical galaxy, the mass density is given by rho equals to k by r. Okay, rho equals to k by r, rho equals to k by r. Okay, from center of the galaxy, if a planet is rotating at r0 distance from the center of the galaxy, find relation between time period t and r0. Okay, cool. So this is galaxy, assume this is galaxy. Okay, and this is r0. Okay, from the center. Okay, so in space the figure is 3D. Okay, so we know we have to balance the gravitation force and the centrifugal force. If there is a planet, there will be attraction due to gravitational force, f of g acting this side, and f centrifugal. So f centrifugal is clear, it will be m omega square by r0. Correct? And fg is also clear, g mass of the object, a planet, here it is planet, g m, sorry, okay, wait, g, okay, so here it will be g mass of planet into internal mass of the galaxy, this mass. Okay, this mass of the galaxy, mass of the internal galaxy by r0 square. Correct? So you have to balance this equation. So first you have to find the mass of inside. So as you know the density, so rho into volume is mass. But you see here density is variable, it is varying with radius and volume. So you take dv anywhere. Okay, dv. So for dv, you know what is the dv? So dv is pi 4 pi r square into dr. Correct? So mass for that small volume will be, a spherical small volume will be from the center, rho into dv. Correct? So you have to do integrate it for 0 to r0. Okay, 0 to r0, 0 to r0. Okay, so the mass will be m, complete mass will be m. Okay, so here you write mass. So mass of galaxy internal will be this one. So use it, you know the rho, you know the dv. So k by r into 4 pi r square dr. Correct? R got cancelled, so the constant will be 4 pi k outside and dr 0 to r0. Correct? Using it, you will find mass internal equals to 4 pi k. Okay, r dr is there, so r square by 2 r0, just integration, a simple integration. So it will become 4 pi k r0 square by 2. Correct? Now you have to just put it. So mass of planet f of c equals to f of g, mass of planet, sorry, here not will be r0 will be here. Okay, mv square by r hota hai, so it will be like m omega square r0. Okay, so mass of centrifugal force, sorry, the centrifugal force will be m omega square r0 equals to g mass of planet, mass internal is 4 pi k r naught square by 2 r naught square, correct, by 2 r naught square. So this will get cancel out, right? Now this mass is cancelled, so omega square will be 4 pi g k by 2 r naught, correct. So omega square is 2 pi gk by r naught. Here g is universal gravitational constant, so omega is under root 2 pi gk by r naught. And you know that omega means 2 pi f, or so 2 pi f is 2 pi gk r naught. So time period will be 1 by 2k r naught. Okay, sorry. F is 1 by 2 pi under root 2 pi gk by r naught. Okay, so it will go inside and it will become gk r naught 2 pi. This is k. Okay, and you know frequency is 1 by time period. So time period will be under root 2 pi r naught by gk. So this is the answer. You have to find in this way. So if you do it fast, quick, and without any calculation mistake, you will find it in 2 minutes. Okay, so it seems longer, but it is not that much longer. Okay, as I am also describing it how we are doing it, so it takes time. Okay, I think you have understand it. In the next part you will see other questions as well. Okay, so if you have any doubt, you can ask me on www.jnveduhub.in. Okay, and all the best. Thanks.